Let's go over tutorial sheet number 4, 2023. Solve each of the following inequalities. So I'll just pick some of these inequalities, starting with the first one here. X squared minus 4x is greater than 3. I'm going to take 3 the other side, so that will give us x squared minus 4x minus 3 is greater than 0. Now if we look at this, we need to find the product, the sum, and the factors. Here the product is going to be, we get a number in front of x squared and then this constant, we multiply them. That will be negative 3. The sum is that value which has got x, that is negative 4. Do we have any two numbers that we can multiply? We get negative 3. If we add them, we get negative 4. The only possible factors is 1 and 3. If we multiply 1 and 3, we will definitely not get a negative 3. So if I put a negative here, negative 1 times 3, of course, will give us a product of negative 3, but the sum will not be negative 4. Even if I had put this negative on 3, still the sum will not be negative 4. So the only way I could have gotten at least something like that is if the sum, the product, was positive. So I would have used also this as negative. So negative 1 times negative 3 would have given us positive 3. Negative 1 minus 3 would have given us negative 4. So meaning that for this one we cannot factorize it. The next option we have is to use the quadratic formula. X is equal to negative b is negative 4, plus or minus square root of b squared, that is a negative 4 squared, minus 4a is 1, and then c is negative 3. That divided by 2a. So this gives us 4 plus or minus. If we work out what is inside, 4 squared is 16, negative 4 times 1 times negative 3, that is a 12. 16 plus 12, that is going to give us a 28. And then we are going to divide that by 2. Now we know that 28 is the same as 4 multiplied by 7. And we know the square root of 4 is a 2. We don't have the square root of 7, is going to give us a decimal. So I can also write that as 4 plus or minus 2 square root of 7 and then divided by 2. And this is the same as, I can factorize out a 2, so that will be 2 open brackets 2 plus or minus square root of 7 over 2. And these 2 can cancel with these 2. So meaning that our values of x, we have got 2 plus or minus square root of 7. This is plus or minus. What does that mean? It means that one value of x is 2 plus 7, the other value is 2 minus 7. So now let's write those values. So I found that x is equal to 2 plus root of 7, or x is equal to 2 minus root of 7. Now remember, this is not an equation, it is an inequation, so we need to find the range of values. So I'm going to write this. So which one is smaller between 2 plus root 7 and 2 minus root 7? Of course, where there is a minus, we expect that to be smaller. So this is just a number line which I'm writing here. So I'm going to write 2 minus root 7 here because it's small, and then 2 plus root 7 here. Okay. So the next thing that I'm going to do is, if I get any value of x between 2 roots minus root 7 and 2 plus root 7, where is it going to, what will be the sign if I put it in this function? Now let me write it like this. Of course, this we said it is the same as x squared minus 4x minus 3 is greater than 0. Now we know root 7. What is the nearest square number to 7? If we go up, it is 9. If we go down, it is 4. The square root of 4 is a 2. The square root of 9 is a 3. So what will be the square root of 7? This means that the square root of 7 will be a number between 2 and 3. So if I say 2 minus root of 7, it means the answer is going to be negative, because the square root of 7 is a number between these two values. So meaning that the square root of 7 is a number greater than 2. I'm doing this because we don't use a calculator, so we need to be strategic as we get to answer this question. So meaning that this is a negative number, while this is a positive number. 2 minus root 7 is negative, 2 plus root 7 is positive. So what number do we know really for sure that it is between a negative number and a positive number? We know of a 0, right? Yes. So we know that 0 is definitely going to be between this region. So what I'm going to do is I'm going to get a 0. If I get 0, I put into this function what to be the value of x. So I put here to be 0 squared minus 4 times 0 is 0 minus 3 is greater than 0. So we can see we have got 0 minus 0 minus 3 simply negative 3. Okay, so that is negative 3 is greater than 0. Is negative 3 greater than 0? We know that is not true. Now what I'm only interested in not is not me to determine whether it's true or not. So when I got a number between 2 minus root 7 and 2 plus root 7, I put that number in this function here. What I'm interested in is to determine the sign. What's the sign that I found? It is a negative. That is what I'm interested in. Now we need to know that for these kind of functions, if this has given me a negative, then this side to give me a positive, and this side to give me a positive. The signs alternate, positive, negative, positive, just like that. So now I'm interested in values of x which are greater than, from what we're able to see here, which are greater than 0. And greater than 0 means positive, meaning that our solution set is going to be from here, going in this direction, and then from here, going in this direction. That is where I've got a positive, meaning that the solution for this inequality is going to be x is going to be, I can write it like this. We are moving all the way from negative infinity up to 2 minus root 7. Are we including 2 minus root 7? No, because it's just the greater than. Union, we are moving from 2 plus root 7. We are going all the way up to positive infinity. So this is going to be the solution set for this question. So we can just pick any other question from this practice. Okay, let me try to pick B, and then we can pick also those which have got a modulus. If we get to pick B, we have got 2 plus x minus x squared is greater than 0. I can rearrange this. I'm going to get this negative x squared, I put it in front, and then positive x, and then positive 2, that is greater than 0. So what will be the product here? The number in front of x squared and the constant, that is going to be a negative 2, and then the sum is a 1. So we look for two numbers that we can multiply to get negative 2. If we add, we get a 1. Two numbers we can multiply to get a 2 is 2 and 1. But now we want to get a positive 1 as the sum. So I'm going to attach a negative here. 2 times negative 1 is negative 2. 2 minus 1 is a 1. So meaning I'm going to write this as negative x squared. And then minus, I'm going to first write this minus 1x. But we don't write 1x, so that will be minus x. And then plus a 2x. And then we now write this plus 2 is greater than 0. We'll factorize out x, that to be, and the negative, that to be negative x, open brackets, x plus 1. And then we'll factorize out a 2 here, 2, open brackets, x plus 1. And that is going to be greater than 0. We get to pair those which are outside. We have got negative x plus 2. And then we have got x plus 1. And that to be greater than 0. If I equate just this 1 to 0, I'm going to have negative x plus 2 is equal to 0. We are going to find that negative x is equal to negative 2, meaning that x is equal to positive 2. So from here, we are finding that x is equal to positive 2. And then from here, if we equate it to 0, we are going to find that x is equal to negative 1. And then I'm going to make again a number line. The smallest value I found here is the negative 1 and then a positive 2. What I'm going to do is I'm going to write these factors which are equated to 0. Now I have got a choice. I can as well just put in this function which is already on top here. Alright, so what I'll just do is I get a number between negative 1 and 2. I know the simplest I can get is a 0. If I put a 0 here, oh sorry, not where there is 2. Where there is x, I'll be putting a 0. I'll put a 0 here, I'll put a 0 here. So this is 2 plus x minus, 2 plus 0 minus 0 squared. That would be 2. Is 2 negative or positive? That is positive, meaning this side to be negative, this side to also be negative. But for this question, I'm interested in range of values where x is greater than 0. That means it's between this region, between negative 1 and positive 2. Meaning our solution set is going to be what? -1, comma 2. We are not including them because this is just greater than. Now, what I was explaining is we can as well write the factors which we have found. One factor that we found here is -x plus 2. So these are the ones now I'm going to write here, -x plus 2. And then the other one, the other factor is here, which is x plus 1. When I equated a -x plus 2 to 0, I found a positive 2. So what happens if I use values of x greater than 2, I put in this function. For example, I get a 3. So it should be -3 plus 2. We can say that is going to give us a negative. So it should be negative. So immediately I cross this 2 for this factor is going to be giving me positive values. And that is something we can prove, right? For example, I get any number less than 2, for example, is 0. I put here -0 plus 2. We know we don't have a -0. That will be a positive. When I equated this one to 0, I found a -1. What happens if I use a great value of x greater than -1? For example, a 2, I put here. 2 plus 1 is positive. So as long as I'm greater than 1 for that factor, I'm going to be positive. As long as I cross -1 for this factor, it will be negative. Now remember, these two values are multiplying. So I'm going to find their product of the sign of the product of the signs of these two functions. Positive times negative is negative. Positive is positive. Negative positive is negative. We can see this is what we already determined, and our solution set is going to be here because we want where this factor is greater than 0. So we can go to something that has got a modulus. Let's work out h. So I've got absolute value of x squared minus 4x is less than 3. Now absolute value means we should take the positive or the negative. So then what do we do for that one? This means I'm going to remove the absolute bar, and then it will be positive or negative x squared minus 4x that is less than 3. So what I'm going to do is I'm going to now split these two functions. So I'm going to have positive x squared minus 4x is less than 3, and then we're going to have negative x squared minus 4x is also less than 3. If I divide both sides by this positive, we are going to have x squared minus 4x is less than 3. If I divide both sides by this negative, we are going to have x squared minus 4x. The sign changes, -3. Every time you divide by a negative for an inequality or you multiply by a negative, the sign is going to change. So this will now give us x squared minus 4x minus 3 less than 0. This side we are going to have x squared minus 4x and then plus 3 greater than 0. Let's find the product here. The product, of course, for the first one, the product is -3. The sum is -4. Do we have any two numbers that we can multiply to get -3? If we add them, we get -4. So this one is similar to the first one that we did, just this one which is here. And we already found those values. We found 2 plus square root of 7 and 2 minus square root of 7. So you can simply go on and try to do that again. So those are the two values of x which we found. X is equal to 2 minus square root of 7 and x is equal to 2 plus square root of 7. And then if we work out this one, the product is a positive 3. The sum is a -4. So for this one, we are going to have factors. What will be our factors? We are going to have negative 3 and -1. If we multiply -3 and -1, we're going to get positive 3. If we add them, we're going to get -4. So this is going to be x minus 3, x minus 1 is greater than 0. I'm interested in just finding the values of x first. This will give us x being 3. This will give us x being 1. Now, we don't want to find the values of x. What we want to find is a range of values of x, because this is an inequality. So then I'm going to remove this. Now we're going to work with this one systematically. We're going to work with both sides. So on this side, look at the values that we have found. We have found x being 2 minus root 7, that is the smallest, and 2 plus root 7. So what we are doing is we are substituting that in this function. We want to find the behavior of the signs. So as we said earlier, 2 minus root 7 is negative, 2 plus root 7 is positive. What number can we get? Simplest. A number between a negative number and a positive number is 0. So if I get a 0, I put into this function. I put 0 here, I put a 0 here. I'm just going to remain with a negative 3. So if I'm finding that our answer is negative, so I'll put a negative between, meaning that this side is going to be positive, this side is going to be positive. And then if I come to this other one, this side, values we have found is a 1 and a 3. So what happens if we get a number between 1 and 3? What number can we think of between 1 and 3? Like a 2. Okay, let me get the simplest. Let's get the number less than 1. Any number that is less than 1 that you know. The simplest I wanted to use is a 0. So if we put 0 here, we put 0 here, we're going to find a positive value. Meaning that this side is positive, this will be negative, and this will be positive. The signs just alternate. For this function, we're interested in where the function is greater than 0, meaning where it is positive. So the solution set for this one is from here going in this direction, from here going in this direction. While for this one, the solution set should be less than 0, meaning that from here up to here. Now, because this was one function, we are going to combine these two solutions to be able to see what will be the final solution for the whole function. So we're now going to write one number line where we have got a 1, we have got a 3. Now what number is 2 minus root 7? Is it less than 1? Is it between 1 and 3, or it is greater than 3? That should be something we should be able to determine. So we already said 2 minus root 7 is a negative number. Definitely is going to be less than 1. So let me just write it here. 2 minus square root of 7. And then 2 plus root 7. We know root 7 is a number between 2 and 3. So if I say, okay, let me get the simplest, which is 2. 2 plus 2 is a 4. It is greater than 3, meaning that that value is going to be somewhere here. 2 plus root of 7. So if I put this function now here, we are going to write from here 2 minus root 7 up to here. And then if we now put this solution on the function, we are going to have from here going in this direction and from 1 going in this direction. So what we want to determine is the solution an intersection of these two solutions or a union of these two solutions? Because we can see if we take union will be the entire of, we are just going to say from negative infinity to positive infinity, because all these lines are joining. But if it is intersection, it will definitely not be true. So let's determine whether it's going to be an intersection or a union. How do we determine? So I'm going to get again the question, absolute value of x squared minus 4x. I can even take the 3 the other side, minus 3 is less than 0. I've just rewritten it. We know 2 minus root 7 is a negative number. 1 is a positive number. Meaning that between here, what are we going to have? We have got a 0. Between a negative number and a 1, which is positive, we have got a 0. So if I get a 0, I put here. This is going to be 0. This is going to be also 0. So I'm going to have absolute the value of 0 minus 3, which is just negative 3. Now the question is negative 3 less than 0? Is negative 3 smaller than 0? We know that is true. So meaning that, yes, this region has proven it is correct. Meaning the intersection, if this intersection is correct, even this intersection is going to be correct. That is how these questions work. So if the intersection set is working, even the other side, if you have an intersection set, is also going to work. Now let's try to get a value on this point where the sets are not intersecting. If it works here, it means that it will also work here where they are not intersecting, even here. But if it fails to work, then it also failed to work on those other three regions. Let's get a number between 1 and 3, like a 2. So 2 squared is a 4 minus 4 times 2 is 8. We are interested in the absolute value. Minus 3 is less than 0. 4 minus 8 is a negative 4. Absolute value of negative 4 is a positive 4. Minus 3 is less than 0. 4 minus 3 is a 1 less than 0. Is 1 less than 0? No. So this is not correct. That also will not be correct. This also will not be correct. So where they are not intersecting those regions, the solution set will not be part. So meaning that the solution set is only part of the intersection, then we are going to write our answer. Solution set is going to be from 2 2 minus square root of 7 comma 1 union 3 comma 2 plus square root of 7. So this is going to be the solution set for this question. So it is the same way that you are also going to work out this other one, which is here. So all you do is write this as positive or negative. You are going to have x squared minus 19 is less than or equal to. Now this is going to be 5x minus 5. I've just multiplied. We can split this. If I get a positive, we are going to have x squared minus 19 is less than or equal to 5x minus 5. And then if I divide through by this negative, we are going to have x squared minus 19. The sign will change. Is less than or equal to, because I'm dividing by a negative. So these signs here will also change. It will be negative 5x plus 5. So it's these two that we are going to solve. And we are going to do in the same way that we have done with the previous one. So you can try to work out that one. Let me do G, the absolute value of 3x plus x is less than or equal to 2. I'm going to take this x the other side. I want to remain with what has got the absolute alone. So absolute value of 3x is less than or equal to 2 minus x. I'm going to say this is positive or negative 3x. I remove the absolute. That will be less than or equal to 2 minus x. And this is going to give us, I'm going to get first a positive, so that will be 3 less than or equal to 2 minus x. And then I'll divide both sides by negative. That will be 3x. The sign changes, greater than or equal to. Because I'm divided by negative, it becomes negative 2, and then it becomes positive x. If I take this to the same side, we are going to have, okay, let me take numbers to the same side. We are going to have 3. I take to this side, minus 2 is less than or equal to negative x. This will give us 3 minus 2 is a 1 less than or equal to negative x. I can as well just swap these. It becomes negative x greater than or equal to 1. So where this region, where this point is looking, is where there is negative x. So I've just changed them. It's still looking that side. So from here, I'll divide both sides by negative so that I remain with x. But immediately I divide by negative, the sign changes. So this is one value of x, or a range of values of x. And then I'll take x also this direction. Then we are going to have, well, actually for this one I forgot an x there, so I was solving it wrongly. So if we get to pair like terms now, I'll take x the other side, so that will be 3x plus x. And then that will be less than or equal to, and then I'll take 2 the other side. 3x plus x, that will be 4x. And that is going to be less than or equal to 2. Divide both sides by x, so meaning that x will be less than or equal to 1 over 2. And then for this one, I take x the other side. That will be 3x minus x is greater than or equal to negative 2. 3x minus x is 2x, that is greater than or equal to negative 2. Divide both sides by 2. That will give us x being greater than or equal to negative 2. We can try to put this on a number line. Negative 2 is here. 1 over 2 is here. Here x is less than or equal to 1 over 2. Meaning it's going to be, actually we are shading this portion. It's going like this. And then for this one, x is greater than or equal to negative 2. Greater than or equal to. So it's starting from here, going in this direction. So now the question is our answer going to be the intersection or the union of these two sets? Then we are going to go back in the original question to find out if it's going to be an intersection or the union of the two sets. A number between negative 2 and 1 over 2 is a 0. So it's the absolute value of 3x plus x. I can take the to the other side, minus 2 is less than or equal to 0. If I put a 0 here, I also put a 0 here. We have got negative 2 is less than or equal to 0. Is negative 2 less than or equal to 0? We know that is true, meaning that the intersection has worked. We can get any number greater than 1 over 2. If it works for this region, then it has also worked for this region where they are not intersecting. We can get a 1 as an example. So I put a 1 here, so we're going to have absolute value of 3 times 1 plus 1 minus 2. 3 times 1 is a 3. Absolute value of 3 is still 3 plus 1. That is going to be a 4. 4 minus 2 is a 2. Is 2 less than or equal to 0? No. So this region has failed. Even this one is going to fail. So meaning now our solution set is going to be from negative 2 to 1 over 2. And we can also see the brackets that I'm using because we are including negative 2 and 1 over 2. So that is going to be that one. Let's look at this one. Use algebra to find the set of values of x for which we also have these different questions. So I also just pick maybe 2, and then the others we can also get to try them out. Let's start with this first one. X minus 4 divided by x plus 3 is less than or equal to 5 divided by x, open brackets, x plus 3. Now one thing that you need to know is when you are talking about rational inequalities, rational because the denominator is a letter. If the denominator is a letter, that is rational. You don't need to cross multiply when you're talking about a rational inequality. Instead, I'm going to get this and take it to the other side. Then what are we going to have? We're going to have x minus 4 divided by x plus 3. Then minus, we are going to have 5 divided by, in the denominator we have got x, open brackets, x plus 3. That will be less than or equal to 0. Now let's do cross multiply. I'm going to multiply this. This is not cross multiplying anyways. I'm just making the denominator the same. Or I'm merging this as a single fraction. So multiply these two. We are going to have x, x plus 3, and then x minus 4. And then we are going to multiply this negative 5 with what is down here. That will be negative 5, open brackets, x plus 3. And then the denominator also multiply the two factors which we have. We have got x plus 3, x, and then x plus 3 again. And that is going to be less than or equal to 0. What is on top we are going to multiply through. If we multiply x with this, that is going to give us x squared. And then x times 3, that will be 3x. We have got also x minus 4. Then minus 5, x plus 3. And then we get to divide everything by, let me write first x, and then we write x plus 3. Now x plus 3 is repeating, so let me just write x plus 3 and then a squared there. And that will be less than or equal to 0. Again, we need to multiply x squared times x, that will be x cubed. X squared times negative 4, negative 4x squared. 3x times 3, that will be 3x squared. 3x times negative 4, that will be negative 12x. Then we multiply negative 5 times x, negative 5x. Negative 5 times 3, negative 15. Divide everything by x, open brackets, x plus 3 squared. That will be less than or equal to 0. Simplifying now, x cubed, negative 4x squared plus 3x squared. That is going to give us a negative x squared. Negative 12x minus 5x That is going to give us a negative 17x, and then minus 15 divided by x, open brackets, x plus the 3 squared less than or equal to 0. So from here we have got a cubic function on top. We need to solve this cubic function. When we are solving that, we can use the try and error method. What are we going to do? Okay, let me write it like this. I'm going to write the factors or the coefficients of x. So the first one, we can see we have got 1 as a number in front of x cubed, negative 1 as a number in front of x to the power 2, negative 17 as a number in front of x, and then negative 15 as a constant. So what I'm going to do here is a try and error method. Let me try to use x is equal to 1. I put in this function. My aim is to find 0 because I want to factorize it. So if I put a 1 here, I put a 1 here, and I put a 1 here, that will be 1 minus 1, which is a 0. Then negative 17 minus 15, that will not give us a 0. Let me try to use a negative 1. So that is going to be negative 1 to the power 3. We know that is a negative 1. And then we put a negative 1 here. Negative 1 squared is positive 1. And then that will be minus 1, because we have got this negative, and then negative 1 squared is a positive 1. So that will simply be a negative 1. And then we have got a negative 17. Okay, if we put a negative 1 here, negative 17 times negative 1, it will be positive 17. And then we have got a minus 15 at the end. Negative 1 minus 1 is negative 2. Negative 2 minus 15 is negative 17. Plus 17 is going to give us 0. So meaning that x is equal to negative 1 is a factor for this one. So I'm going to write here x is equal to negative 1. Now I want to find the other factors. I'm going to put a 0 here. We are using the synthetic method. 1 plus 0 is 1. 1 times negative 1 is negative 1. Negative 1 minus 1 is negative 2. Negative 2 times negative 1 is positive 2. Negative 2 plus 2 is negative 15. Negative 15 times negative 1 here is positive 15. And negative 15 plus 15 is a 0. Meaning if we factorize what is on top, the first factor we found is here. We are going to take 1 the other side. So that will be the first factor, which is x plus 1. The other factor is this one. This is a quadratic. We just put x squared in front here, and then we put x here. And then the others, the negative 15, we just write it like that. So this is going to be x squared minus 2x minus 15. And then in the denominator we have got x plus 3 squared, and that is going to be less than or equal to 0. We can as well factorize the quadratic that is on top if it is able to be factorized. So we can see from there what is the product. The product is negative 15, and then the sum is negative 2. Do we have any two numbers that we're able to multiply to get negative 15? If we add them, we get negative 2. What two numbers can we multiply to get a 15? We have got 1 and 15 itself. We have got 3 and a 5. So if I use a negative 5 and a positive 3, I'm going to get a product as negative 15. And then negative 5 plus 3, I'm going to get the sum as negative 2. So those are the two factors. Meaning this is going to be x plus 1. If we factorize this, we are going to have x minus 5 and then x plus 3. In the denominator, what do we have? We have got x plus 3 squared, and that is less than or equal to 0. Now that we have fully factorized this, we can now equate the denominator to 0, equate the numerator to 0. If I equate the numerator to 0, we are going to find that x is equal to negative 1 if we equate this one to 0. If we equate the next one to 0, we're going to find that x is equal to positive 5. If we equate the other one to 0, we're going to find that x is equal to negative 3. And then if we equate the denominator to 0, what are we going to find? We're going to find that x is equal to If I equate x to 0, I'm going to find that x is equal to 0. If I equate this one to 0, I'm going to find that x is equal to negative 3. So these are the values that we found. Now we need to put this on a number line to determine the solution set. We have got 4 different values that we have found. The smallest value that we have is negative 3, followed by negative 1, followed by 0, and then a 5. Now we need to look at all the factors that we equated to 0, and then we're going to put them here. So the first factor is, I can write x. The next factor that we equated to 0, I can write x plus 3. The other factor that equated to 0 was x minus 5. And then the other factor that equated to 0. Anyway, just to simplify this one, because as I can see, it's going to be very tricky when we get to write it like this. Again, even if these are repeating, when we are putting into this function to determine the sign, we need to write it twice because it changes everything. So that is going to be x plus 3. So let me work first with what is on top, and then I work with what is down. I think it is going to be easier in that way. So I'm first working with what is down, and the factors that we found when we equated what was down to 0. So I just found 0 and negative 3. So I'm going to remove this. I'm also going to remove this. But how many factors do we have in the denominator? We have got 3. The x plus 3 is appearing twice. So don't forget that. Write it also twice. Alright, now we can try to find out what the signs are going to be. When we equated x to 0, we found a 0. What happens if I use a value of x greater than 0? That is going to give me a positive value. Immediately I cross 0 for that factor is going to be negative. When I equated x plus 3 to 0, I found a negative 3, which is here. What happens if I get a value of x greater than negative 3? I put in this function. For example, negative 2. Negative 2 plus 3, that is going to give us a positive value. And immediately I cross the sign, is going to be negative. It is the same with this one. There were 2. So negative, positive, positive. Now here I'm interested in, because these are multiplying, so I'm interested in the product. So this will be negative, this will also be negative, and then this is going to be positive. Okay, that is how it's going to move. Let me just confirm it again. X 0, it was positive and then negative. Okay, and then these two are the same, so that is okay because those two are the same. All right. So what I'm interested in are these signs. These are the points of interest. So let's just keep these values, these signs which we've found. We have got negative 3 and 0. The signs, we have got negative, negative, and then positive. Now I can write those which are on top. The first one we found on, okay, let me first write this. We have got 3 values that we found. The smallest being negative 3, followed by a negative 1, and then a 5. We also need to write the factors that we've equated to 0 for us to be able to determine all these values. We have got x plus 1, x minus 5, x plus 3. When I equated x plus 1 to 0, I found a negative 1. What happens if I get a value of x greater than negative 1? For example, I get a 0 is greater than negative 1. I put here. It's going to give us a positive. Immediately I cross a negative 1, it will be negative. When we equated x minus 5 to 0, I found a 5. What happens if I use a value of x greater than 5? For example, a 6 is going to be positive. Immediately I cross to give us negative. When we equated x plus 3 to 0, we found a negative 3. What happens if we use a value of x greater than negative 3? For example, we can use a negative 2. Negative 2 plus a 3, that is a positive number. And immediately we cross a negative 3 is going to be negative. And again, I'm interested in the product of these signs because these factors on top are also multiplying. So I've got negative 3, we have got negative 1, then we have got a 5. So negative, negative, negative is negative, and then this is positive, this is negative, this is positive. Now we need to combine all these factors together to be able to determine now what the solution set is going to be. So the first one, the smallest we have is negative 3. The next one we have is the negative 1. The other one that we have is a 0, and then we have got a 5. So I'm going to start with this one. And this one is just between negative 3 and 0. So as long as we are less than 0 is negative, and as long as we are greater than 0 is positive. And then for the other one, when we are less than negative 3, it's negative. Between negative 3 and negative 1 is positive. Between negative 1 and 5 is negative. Negative 1 and 5 is negative. And then greater than 5 is positive. Now these factors on top are dividing with these factors down. When you divide signs, they are going to be able to change. So I'm also interested in the quotient of signs. Negative, negative is positive. Positive, negative is negative. This will be positive. This will be negative. This will be positive. Now for this function, we're interested where the values of x are less than or equal to 0. What does that mean? Less than or equal to? We are interested in where they are negative. So it is from here up to here. As you can see, I am shading. Why am I shading? Because it's less than or equal to 0. And then also from here up to here. Now even if it is less than or equal to 0, the denominator can never be equal to 0, right? So the denominator can never be equal to 0. So anything which is giving us 0 in the denominator, we are not going to include it. In the denominator, we equated this one to 0, it gave us 0, meaning that for 0, it can't be part of the solution. When we equated x plus 3 to 0, we found negative 3. So negative 3 will give us a 0. It can't be part of the solution. So this is how we are going to be able to determine the solutions. Therefore, solution set is going to be from negative 3 to negative 1, and then from 0 up to 5. So if you write this as closed instead of it open, you have definitely lost the mark. So that is how we get to work out this. Now because this question was too long, I'm just going to do one more, and then the others we are able to try them out. So it is all the same for everything that has got a rational. Just take also this one, also this one, also this one. You don't cross multiply. Instead, take them to the same side, merge as a single fraction, and then work it out. So let me try to work out this one b. Absolute value of x squared minus 9 is less than absolute value of 1 minus 2x. For this one, even if you can see two absolute bars, it's the same as the previous question, question 1, which we did. So simply get any one function, put positive or negative, and then the other one, just remove the bars. So if I get a positive, we're going to have x squared minus 9 is less than or equal to 1 minus 2x. If we get this negative, divide both sides by that negative, we're going to have x squared minus 9. The sign changes greater than or equal to. Even these will change signs, negative 1 plus 2x. This will give us x squared. I'll take this to the other side, it becomes positive 2x. I'll take one the other side, negative 9 minus 1, that will be negative 10, to be less than or equal to 0. And then this will be x squared take the 2 the other side, negative 2x. Take the negative 1 the other side, that would be negative 9 minus 1. That is going to be a negative. Okay, I think I also erred on this one when I took the other side. Oh, it was just fine. So the only thing is this one is negative. Negative 9 plus 1, that would be negative 8. And that is going to be greater than or equal to 0. So when we get to look for the product is negative 10, the sum is 2. Do we have any two numbers we can multiply to get 10? If we add them, we get 2. That is going to be difficult. I don't think we have those. Do we have any two numbers we can multiply to get 8? When we add them, we get a 2. The products, we have got 4, 2 for this one. If we multiply those two. Now I want to get a negative sum. I'm going to put a negative on this one. So meaning this is going to be x minus 4, then x plus 2 is greater than or equal to 0. Finding that x is going to be 4 if I equate to 0, and then x is going to be negative 2 if I equate to 0. For this one, we'll not be able to find the value, so we need to use the quadratic formula. X is going to be negative 2 plus or minus square root of 2 squared minus 4ac divided by 2a. And this gives us negative 2 plus or minus 2 squared, that is a 4. Negative 4 times negative 10, that is a positive 40. So that is going to give us a square root of 40, then divided by 2. Now square root of 40 is the same as square root of 4 times 10. And we know square root of 4 is a 2, so this is going to be negative 2 plus or minus 2 square root of 10 divided by 2. We can factorize that. That will be let me say a 2, open brackets, negative 1 plus or minus square root of 10 divided by 2. This will cancel with that, meaning that the values of x, we have got x being equal to negative 1 plus or minus square root of 10. Now I'm going to write those values under this one. And okay, for the other one, this side, let me just remove this point because we already know the values. So for the first one here, we have found that x is equal to negative 1 plus the square root of 10, or x is equal to negative 1 minus the square root of 10. And then for the other one, the factors are already there. Now we need to find the solution set. Which one is smaller, negative 1 plus square root of 10 or negative 1 minus square root of 10? So this one, both are negative, meaning that it is a negative number. So that's the smallest. And then we have got square root of 10 minus 1, which is the same as negative 1 plus square root of 10. Now for this one, of course, square root of 10 minus 1 is a positive number because square root of 10 is somewhere 3 point something. So this is negative, this is positive. We can get a number between those two values, which is a negative value. We put 0 here, we put 0 here. Sorry, I meant we get a number between this negative 1 minus 10 minus root 10 and root 10 minus 1, which is the simplest we can get is a 0. We input in this function where there is x. So 0 squared plus 2 times 0 minus 10, it will give us a negative value, meaning that this side is going to be positive, this side will also be positive. For this function, we're interested where it is less than, meaning that our solution set for that one is between here. And then if we come to this other one, we have got a negative 2 and a 4. If we get a number between negative 2 and 4, the simplest we can get is a 0. I put 0 here, I put 0 here to be negative 8. Is negative 8 truly greater than or equal to 0? It is not. Okay, let me go back to this one. I see what I did here. Here the sign is less than. Okay, less than, that is correct. So for this one, if we get a 0, we put in this region. What are we finding? We are finding a negative value. this side, then it is going to be positive, this side is going to be positive. We are interested where it is greater than 0. So it is starting from here. I was supposed to shade this because it's greater than, less than or equal to. So the solution will go in this direction, also from here going in this direction. Now we are supposed to put these two on the same number line and then determine the solution set. -1 minus -10, we said -10 is somewhere -3 point something. So this is about -4. So it is the smallest value we have, followed by -2, and then followed by root of 10 minus 1, and then 4 is the biggest. Now we can look at the signs that we have here. Okay, we have already found the solution sets from between negative. Okay, what have I written? So I haven't written this one. I've written it in a wrong way. It's this one here. That is supposed to be -1 minus root of 10. So I've got a solution set between here, and then I've got a solution set from 4 up to infinity, from here going in this direction, and then from -2 up to -infinity, so from here going in this direction. Now the question is, what will be our solution set? Let me write this in a different color. Is our solution set going to be an intersection or the union of these two sets? So if we look at this region, we have got a numbers greater than 4. We can get a 5 and input in the function that we have. We see if it's going to be true. So the function we're talking about is absolute value of x squared minus 9 is less than absolute value of 1 minus 2x. So if I get a 5, I put a 5 here. 5 squared is a 25, and that is 25 minus a 9, which is 16, and we know absolute value of 16 is still 16, and that is less than, we have got 1 minus 2x, and we are saying x, the value we have gotten to use is a 5. So 2 times 5 is a 10. 1 minus 10 is a -9. Absolute value of -9 is a +9. Is 16 less than 9? This is not true. So this has refused. So for me, the moment I see that where there is no intersection, it refuses, it means that even this is going to refuse, even this is going to refuse. The only value that is going to work then is going to be the intersection. So you can conclude that the solution set is from -1, -1 minus root of 10, -2, and we're including both values. So that is how you work out that one. We can consider this one. Solve each of the following equations. Now for equations, they are much simpler to be able to solve. So let me start with the first one. We have got 1 over x is equal to 4 divided by 3x plus 1. I can merge this as a single fraction. So we're going to have 1 divided by x is equal to, this is the same as over 1. We'll multiply this 4 on top with the 1 down, that will be 4. Multiply the 3x times the 1 on top, that will be 3x. So multiply the two denominators, that will be 3x. Now for rational in equations, we can even cross multiply. So this will be the 1 on top times the 3x down, that will be 3x. And that will be equal to x down times the 4 on top, that will be 4x, times the 3x on top, that will be 3x squared. We take everything to the same side. We are going to have 3x squared plus 4x. This 3 goes the other side, that will be -3x, and that is going to be equal to 0. So this is 3x squared, 4x minus 3x, that is positive x. That will be equal to 0. We're going to factorize out x, so this is going to be x divided by, x open brackets, 3x plus 1, that is equal to 0. Now equate this one to 0, we're going to find that x is equal to 0. Equate this one to 0, we're going to find that x is equal to -1 over 3. So those are the two values of x. So it is the same way that you work out any rational equation. Same with this one, which is here. Simply merge them as a single fraction. Maybe you can get to try that also. 1 divided by x minus 1 plus x divided by 3x minus 2, that is equal to 1 over 3. Multiply the the number on top of the first fraction with the number down the second fraction, that is 3x minus 2. Multiply the x on top with the fraction with the values down here. That will be positive x squared minus x, and then multiply the two denominators. That is going to be 3x squared minus 2x minus 3x plus 2, and that is going to be 1 over 3. So from here we have got x squared, 3x minus x, that is going to be 2x, and then minus 2 divided by the denominator. I've got 3x squared minus 5x plus 2, and that is going to be 1 over 3. From here again we can cross multiply. We'll multiply this 3 with what is on top. So that will be 3x squared plus 6x minus 6, that is going to be equal to 3x squared minus 5x plus 2. If we take these two to the same side, they'll cancel out. If I take 5x this side, it will be 6x plus 5x, that will be 11x. I take 6 this side, it will be 6 plus 2, that is going to be 8. So x is going to be 8 over 11. And then we work out, let me get anyone, let's get C. Square root of x minus 4 is equal to square root of 4x. So for this one, simply square both sides. So we're going to square this side, you're also going to square this side. You are going to remain with x minus 4 being equal to 4x. Take the letters to the same side to be x minus 4x is equal to 4. This will give us negative 3x, that is equal to 4. X is going to be equal to negative 4 over 3. So that will be the value of x. Now we need to be really careful when it comes to rational equations, because you can't have the square root of a negative number. So now that we have found this, we should be able to check our answer. So we are going to say square root, where there is x, we are going to put negative 4 over 3, then minus 4. This is equal to square root of 4 multiplied by negative 4 over 3. And this here will give us square root. This is going to be negative 4 minus 12 divided by 3, and that is equal to negative 16 divided by 3, the root. Negative 4 minus 12 is negative 16 over 3. And that is equal to square root of negative 16 over 3. Now even if these two are equal, we can see that we are finding the root of a negative number. We don't have the root of a negative number. So that gives us that the solution set is an empty set. Where you are finding, of course you have found the value, but it is giving you a root which is negative here. That means that is not a solution, even if it's an answer from the solving. So you should always get the root of a positive number, not a negative number. Okay, let's work out E, which is the square root, and then square root of x minus 5 plus x is equal to 5. So what do we do for this one? We are going to square both sides. We are going to remain with square root of x minus 5 plus x is equal to 25, because this square and this root will cancel. I'm going to take this x the other side. Going to have root of x minus 5 is equal to 25 minus x, and then square both sides. Now when you are squaring, always put this in brackets. So we're going to have x minus 5 is equal to 25 squared which is a 625, minus, we multiply this 2 times 25 times x, that is going to be negative 50x, and then x squared, that will be positive x squared. From here we arrange like terms together, that is going to give us x squared. I'll take this x the other side, that will be negative, so that will be negative 51x. I'll take 5 also the other side, it becomes positive, so that will be positive 5 plus 625, that is going to be 630, and that is going to be equal to 0. So from here, these numbers are too big, so the simplest we can do is get to use the quadratic equation to be able to solve that. So x is going to be square root, we first get the negative b, which is 51, plus or minus square root of negative 51 squared minus 4, a is 1, and then c is 630, divide everything by 2a. So simply work out this, just simplify it, because of course it will give big numbers, that will give us the value of x. We can just go on, this is going to be 51 plus or minus the root of 51 squared, that is about 2600, and then minus 4 multiplied by 630, that is going to give us 81. Then we divide that by 2. What is the root of 81? The root of 81 is a 9, and then we divide that by 2. So what we have is 51 plus 9, which is a 60, divided by 2, or 51 minus 9, and that is going to be a 42, divided by a 2. So this is going to give us 30, or x is going to be equal to 21. So that is how you get to work that one out. So same, that is how we're going to be able to work out the remaining ones. Now just I, which has got 2 roots, so the procedure to take for that one, you have got root of 11 minus x minus square root of x plus 6 is equal to 3. What you do is take one root the other side, so that you just remain with 1. Or you can just put them together like this, and then you get to work them out. But best you take one root, so that you just remain with one root one side. So that is going to be square root of x plus 6. It was negative, it becomes positive, and then plus 3. Now you square both sides. So it's going to give 11 minus x is equal to, when you have got a plus b squared, this gives you a squared plus 2ab plus b squared. So get the first number here, you square it, that is going to be x minus 6, the root goes, and then get the power 2 multiplied by 3, multiply also by this. So that is going to give us 6 root x minus 6. And then now get the 3, you square it. That is going to give us a 9. Again, take everything to the same side, let the root remain alone. So we're going to have 11 minus x. We'll take this x also minus x, and then plus 6, then minus 9. That is going to be 6 root x minus 6. So this will give us 11 minus plus 6 minus 9. That gives us 8. Then minus 2x. That is equal to 6 square root of x minus 6. We can divide both sides by 6 just now, or we can wait to divide. So let me first square. I'll square this side and also square this side so that the root goes. Here I've got 80 squared, which is a 64, and then we are going to have 2, which is the power times 8 times 2, which is the same as 4 times 8, and that is a 32, negative in this case 32x, and then negative 2x squared, that will be positive 4x squared, and that will be equal to 6 squared is a 36, and then the root is would have gone. Now we are going to remain with x minus 6. So this one which we have here is what we want to simplify, and we have done quite a lot. This is a quadratic. Simply simplify it and then solve for the values of x. Solve each of the following equations. So for this one also, I'll just pick few. Let me just pick two questions. I'll pick A and F, since the other ones they are similar. Okay, I can also pick, let's say, B. Now the first one, x to the power negative 4 minus 8 x to the power negative 2 plus 15 is equal to 0. I can as well write this as, we know according to the rules of indices, we can split powers. So this is going to be x. I can write this as x to the power negative 2 and then 2. Because if I multiply negative 2 and 2, it will still give me negative 4, and then minus 8 x to the power negative 2 plus 15 is equal to 0. Then from here we'll just say we can get any letter. Let b be equal to x to the power negative 2. So where there is x to the power negative 2, I'm going to put b, but that is squared. And then minus 8, where there is x to the power negative 2, I also put b, and then plus 15 is equal to 0. We now solve this one. The product we have is 15. The sum is negative 8. Any two numbers that we can multiply to get negative 15, if we add them we get negative 8. Got negative 5 and negative 3. So this is going to be b minus 5 and then b minus 3. That is going to be equal to 0. Meaning that b is going to be equal to 5 or b is going to be equal to 3. Now we are not interested in finding the value of b. Here we want to find the value of x. We will say but x to the power negative 2 is what is giving us a b from this one. So this will be x to the power negative 2 is equal to, where there is b, I'll put 5, or x to the power negative 2 is equal to, where there is b, I'll put 3. I can as well write this as, okay, we can go on and simply get the value of x. Simply multiply by the reciprocal. So multiply this by negative 1 over 2. Also this side by negative 1 over 2. So this will cancel. X will remain 5 to the power negative 1 over 2. And we know according to the rules of indices, this can be changed to become a positive power. So becomes like that. Or same here, this is going to be x. We'll multiply by negative 1 over 2. Also here by negative 1 over 2. This can also be changed. It becomes a positive power. This means this is the same as 1 divided by square root of 5, or x is equal to 1 divided by square root of 3. So these are the values of x. So that is a similar root we are going to also use for this one, which is b. So I'll not finish it. I'll simply end at where we can take it up, and then we can proceed with working it out. So what we have is x to the power 6 plus 7x to the power 3 minus 8 being equal to 0. I can write this as x to the power 3, and then I write a 2, and then plus 7x to the power 3 minus 8 is equal to 0. What do you do? Let b be equal to x to the power 3. So this is going to be b squared plus 7b minus 8 is equal to 0. I think we can even see the answer here. The product is what? Negative 8. The sum is a 7. So the product is negative 8, the sum is 7. So we can have our factors as negative 8. Okay, we can have positive 8 and a negative 1. If we multiply, we're going to get negative 8. If we add, we are going to get a positive 7. So this is going to be b plus 8, and then b minus 1 is equal to 0, giving us b being equal to negative 8 or b being equal to positive 1. But we are not interested in b. We want to find the value of x. So say x to the power 3 is equal to b. So this means that x to the power 3 is equal to negative 8, or x to the power 3 is equal to positive 1. We now need to find the cube root of both sides to find the value of x. So I could have multiplied by 1 over 3, which is the same. So that will give us a negative 2, or x is equal to a 1 here. Alright, so that is going to be it if we also take the cube root of x this side for this one. Now we can work out f. Since d is similar with what we have just been working out, and also e, we simply put every term that doesn't have the root to the same side, and then we square both sides to be able to find the value of x. So for f, we have got x plus 1 over x, and this is squared, minus 2x plus 1 over x, and then plus 1 is equal to 0. How do you get to work it out? So there are a lot different ways in which we are able to solve such a question. So one way is we can even expand if we want, and then get to simplify it, or we can factorize, and whatsoever that we're able to do, we can still run to the answer. So let's say I merge what is inside as a single fraction. What we are going to have is x squared plus 1 divided by x, and this is squared, minus 2. We are going to have x squared plus 1 divided by x, and then plus 1 is equal to 0. So from here, if I wanted to factorize, that will still bring me back. So let me just expand. I'm going to square both sides. So what we are going to have, I'm going to square what is on top and what is down. Now if I square what is on top, we're going to write it as x squared plus 1, and then squared. So this square like that. And then in the denominator, we're just simply going to have x squared, and then minus, we have got a 2, we have got also x squared plus 1, and then divided by x plus 1, and that is equal to 0. If I try to factorize out from the denominator an x, what are we going to have? We are going to have x in the denominator like that. If I try to factorize out x squared plus 1 on top also, what are we going to remain with on top? We are going to remain with x squared plus 1 divided by x, then minus a 2, and then plus 1, that will be equal to 0. So from here, what we are able to see, we will not proceed anywhere. So simply let me expand on top and in the denominator, and then we are going to simplify those. So we are going to have x squared. What we do is you get the first number, you square it, so that becomes x to the power 4. You get the 2 multiply with what is inside, that will be 2x squared, and then you get a 1, you square it, and then divided by x squared minus, let's multiply with a 2x squared, then negative 2. This 2 has got a negative, we are just multiplying with what is inside there, and that is going to be divided by x, and that is going to be plus a 1 is equal to 0. We can merge everything as a single fraction. Now I've just taken a wrong and a tough path for this one. Of course we can proceed with that, but it's going to just be long. Let me take a shorter path. You can continue with that one if you want, you see where it goes. So let me just say let b be equal to x plus 1 over x. So I'll put a b here, that will be squared, then minus 2, I'll put a b here, then plus 1, and that will be equal to 0. The product here is a 1. The sum is a negative 2. What will be the factors? It is a negative 1 and another negative 1. Meaning that this is going to be b minus 1 and then b minus 1. And that is going to be equal to 0. We are finding that b is only equal to positive 1. And then we'll now come back. But x plus 1 over x is equal to 1. Alright? Because we said that b is equal to x plus 1 over x. So where there is b, I now put a 1. And then we can now make this as a single fraction. That will give us x squared plus 1 over x is equal to 1. Cross multiply, that will give us x squared plus 1 is equal to x. And this gives us x squared minus x plus 1 is equal to 0. So for this one to solve it, we can use the quadratic equation. We're going to find that x is equal to negative b, which is negative 1, plus or minus square root of b squared minus 4ac over 2a. And this will give us positive 1 plus or minus negative 1 squared minus 4. That is going to be root of negative 3 divided by 2. So we don't have solutions for this one because we have got a root of a negative number. Find the domain and range of the functions below. Sketch their graphs. When you want to sketch rational graphs, okay, not rational but radical graphs, we have got a root. You have got a number inside. Simply equate that to 0. 3 plus x is equal to 0. X is giving us negative 3. So this is where the function is going to start at x is equal to negative 3 here. Now look at the value of x and the value of the function. From what you're able to see, x is positive, meaning that the function is going to be going forward to positive values of x. And then the radical is positive, meaning the function is going to be going towards the positive values of y. So that will be the direction of this radical, forward and up from 3. So it's going to be going like this. So the only thing that we need to find is where it's cutting the y-axis, and at that point x is equal to 0. So this is going to be root 3. If you just put a 0 where there is x there, you're going to find root 3. So that is how you sketch that one. And then for the next one, we have got 3 minus 1, 3 minus square root of 1 minus root 2. So again, equate what is inside the root to 0. We're going to find that x is equal to negative 1 over 2. Is it negative 1 over 2 or positive? We are going to first take 1 this side, it becomes negative, divide by negative 2, so it will be positive. We can now sketch that graph. Now the first thing here, we can see that x has moved to positive 1 over 2, but y has also moved. So this constant that we're able to see here shifts the function in the y direction. So the function will be starting from here. So this will be the beginning point of the function. Now if you look, x has got a negative attached to it, so the function will be going in this direction. And then the radical has got also a negative attached to it, so meaning the function will be going down. So it will be going to the left and down. Now the chances are it can come and cut at this point, it can come and cut on the middle, or it can come and cut here. So how do you determine what's going to pass? Because you'll not just draw even if you know that it's coming to the left and down. So let's say when x is equal to 0, where is it going to cut the y-axis? Is it at a positive value or a negative value? So if x is equal to 0, put a 0 here. You are going to have square root of 1, which is a 1. 3 minus 1 is a 2. So we can see where the function is going to cut. It is cutting at 2. So meaning the function is going to come and cut like that. So that is how the function is going to be able to move. And another point that we need to find is this one, when y is 0. So simply put 0 where there is f of x, so that will be 0 is equal to 3 minus square root of 1 minus 2x. I'll take this the other side, it becomes positive 1 minus 2x is equal to 3 square both sides, that will be 1 minus 2x is equal to 9. Take 1 the other side, negative 2x is equal to 8, and then x is going to give us negative 4. So this is negative 4 here. You need to make sure that all intercepts are included when you are sketching these functions. Then for the last one, when we get what is inside to 0, we're going to find that x is equal to 1. So we have got x being 1, and y, the function has shifted to negative 1, so it's here. It has been shifted like that. Now from what we're able to see, x is positive, the function is going to be going forward. Also y is positive, the function is going to be going up. So how will be the function going forward and up? It will be going in this direction. So the only value we need to find is this one, and this is when y is 0. So that will be 0 is equal to square root of x minus 1 minus 1. Take 1 the other side, it will be 1 is equal to square root of x minus 1. Square both sides to remove the root, to be 1 is equal to x minus 1. Take 1 this side, x is going to be 2. So this is 2. And that is a sketch. Solve each of the following. Now we have solved similar of these equations. So let me just get 2. I can pick A and F. So I've got absolute value of 2x minus 5 is equal to 9. We say it can either be positive or negative. We remove the absolute bar, and that will be equal to 9. So it will be 2x minus 5 is equal to 9, or I'm now going to divide both sides by this negative. So that will be 2x minus 5 is equal to, it becomes a negative 9. There is no sign which is changing because it's not an inequality. If it was an inequality, the sign changes when you divide by a negative. So this will be 2x is equal to, I'll take 5 the other side, 9 plus 5 is 14. So x is a 7. Then 2x is equal to, take 5 the other side, 5 minus 9 is a negative 4. So x again is going to be negative 2. So these are the two values. That is how you work out also with the rest. Now let's try f. Absolute value of 2x minus 1 is equal to absolute value of 4x plus 9. Again, say positive or negative, you get 2x minus 1. For the other side, just remove the absolute bar. This will give us 2x minus 1 being equal to 4x plus 9, or 2x minus 1 being equal to, divide both sides by negative, to be negative 4x minus 9. Take them to the same side. Take this 4x this side. 2x minus 4x, that is going to be negative 2x, and that is going to be, take 1 this side. 9 minus plus 1, that is now a 10. So x is going to be negative 5. Also this side, take the negative 4 this side. That is going to give us 6x. Take negative 1 this side. It becomes positive 1. 1 minus 9, that is a negative 8. And that is going to give us x being equal to negative 8 divided by 6, which is negative 4 divided by 2. Redefine each of the following absolute value functions by removing the absolute value. Hence sketch the graph of each function. Again, we'll just pick 2. Let me get A and B, and then you can try out C. So to redefine a function, we have got f of x is equal to absolute value of 5x minus 4. So what you want to do is to remove the absolute bars. What am I going to do? I'm going to equate this to 0. We are going to find that x is going to be, okay, to be 5x minus 4 is equal to 0. 5x is equal to 4. So x is going to be 4 over 5. Now what you do is this. We have found that x is equal to 4 over 5. We are now going to get this function. We have got a 4 over 5 here. If I get a value greater than 4 over 5, we know 4 over 5 is 0 point something. Let's say I get a 1 because I know it's greater than 0 point something. If I get a 1, I put here. What will be the value of the function? It is going to be 5 times 1 minus 4, which is positive. If I get a number less than 0 point something, let me say I get a negative 1, I put here. What will be the function? 5 times negative 1 minus 4 is going to be negative. Now from the definition of a absolute value function, it can't be negative. So to redefine this function, we'll say f of x is equal to, I'm going to write this as 5x minus 4, again 5x minus 4. We can have x being greater than or equal to negative 4 over 5, or we can have x being less than negative 4 over 5. Now it's up to me to put also less than here. It doesn't matter. I can put less than or equal to, or greater than or equal to there. So the equal to which I'm putting doesn't matter. I could have put this instead of there. I could have put it here, or I can put it at both. Now it's just better I put it on one. It just shows that the function is continuous. It doesn't cut. Now for values of x greater than or equal to negative 4 over 5, we are saying that the function is what? Positive. Yes. For values of x less than negative 4 over 5, less than meaning going in this direction, we are saying the function is what? Negative. But from the definition of an absolute value function, it can't be negative. As long as something is in the absolute, it's always positive. Meaning that I need to multiply this by a negative to make it positive. Negative times negative will be positive. So for this part which is giving us less than or equal to negative 4 over 5, I need to multiply this part with a negative to make it positive. That is what we mean by redefining. So this means that f of x is going to be 5x minus 4 for x is greater than or equal to negative 4 over 5, and then negative times 5x and then times negative 4, that would be 4 minus 5x, and this is for x is greater than negative 4 over 5. So these are the two functions which do apply when we redefine the function. And now we can sketch. It is easier to sketch when you just have one absolute bar. So simply equate to 0 what is inside the brackets there, or inside the absolute value, and we've already found negative 4 over 5 as the value. Was it even negative, or I've just messed it up? It was supposed to be positive when equated to 0. So I've got a 4 over 5. So what this function behaves is that, okay, we can see that as long as we are talking about values of x greater than 4 over 5, we are going to be working with this function. So if I get 4 over 5 itself, I put where there is x, I'm going to get 5 times 4 over 5 minus 4, well, that will be 0. So the first coordinate we have is 4 over 5 comma 0. For this function, I'm only getting values which are greater than 4 over 5. The next value I can get is, let's say, a 1. I put here. It will give me also a 1. So it will be 1 comma 1. So the next value will be here. The next point I'm going to get is a 2. I'm only getting values which are greater than 4 over 5. I can't get anything less than 4 over 5 for this function. Like a 2. I put here. 5 times 2 is a 10 minus 4. That is going to be a 6. So you have got 2 comma 6. 2 is somewhere here, 6 will be somewhere on top there. So this function will continue going in this direction. If we come to this one, it is only applying for values of x less than 4 over 5. Now I even swapped this. This was supposed to be greater than or equal to this one, supposed to be less than. I swapped them. Hope we saw what I wrote on the previous page. So for this one, it will be going in this direction. That is how you sketch this function. It is easier. So if you just look at it, you just equate what was in the absolute bars to 0. Just take 1 going in this direction, 1 going in this direction. So if this function at the negative here, The only thing is it would have turned down, it would have been going like this. So the only thing that we need to find is where this function is cutting the y-axis, and we know that happens when x is equal to 0. So put 0 here. 5 times 0 is 0, minus 4 is negative 4, but remember it's absolute, so that will give us a positive 4. So this is positive 4 where it is cutting that axis. We can work out b. F of x is equal to the absolute value of 2x minus 1 minus absolute value of x plus 2. Again, also for this one, equate this one to 0. You are going to find that x is positive 1 over 2. Equate this one to 0. You are going to find that x is equal to negative 2. Now, when we do this, the next thing that we are going to do is we want to redefine this function. So write as f of x is equal to, we have got three values here. How are we going to work it out? So the first, get and put this on a number line. The smallest we have here is x is equal to negative 2. And then we have got x is equal to 1 over 2. These are the two values that we have. I'm going to get this value which is in. Let me start with this one. What is inside here? I'm going to write it here, 2x minus 1. And then I also write this 2x, that is just x plus 2. When I equated this one to 0, I found a 1 over 2. What happens if I get a value greater than 1 over 2? I put in this function. An example I can get is a 1. So I put here 2 times 1 is a 2, minus 1 is a 1. Is that positive or negative? It's positive. So this side is giving me positive. So immediately I cross the 1 over 2 to give me a negative. When I equated this one to 0, I found a negative 2. If I use a value of x less than negative 2, let's say the simplest I can get is a 0 I put here. Is it going to be positive or negative? It's going to be positive. Meaning as long as I cross negative 2, okay, let me just refer to that again. When I equated x plus 2 to 0, I found a negative 2. If I use a value of x greater than negative 2, a 0 is not less than negative 2, it's greater than negative 2, it's going to be positive. So immediately I cross negative 2, it will give me a negative. So we can see how the function is behaving with a sign. So for here, I don't need to find the product because these are not multiplying. So then what am I going to do? I'll simply get these functions. Remember, we have got three regions. We have got values less than negative 2, between negative 2 and 1 over 2, and greater than negative 2. Those are the three regions that we have. So we are going to write three different equations. So I'll copy this the same way it is. We have got 2x minus 1. Let me just put it in brackets. And then we have got a minus there, this one. All I've done is removed the absolute bars. And then x plus 2. I'm going to write for values of x less than or equal to negative 2. I'll write this one again, 2x minus 1, then minus x plus 2. Now for values of x between negative 2 and 1 over 2. Again, it doesn't matter whether I put less than or equal to. If you want, you can just be putting everything less than or equal to, less than or equal to. All I'm interested in is to show that I've got values here, I've got values here, and values greater than. I'm also going to write this again, 2x minus 1, then minus x plus 2. Now for values of x greater than or equal to 1 over 2. If you've noticed, here I used less than or equal to. With negative 2 here I haven't put a equal to. With 1 over 2 I used equal to here, I have not used equal to. That is all I'm doing. But if you want, you can use equal to at every point if you are confused with what is happening. After we do this, now we just go to the signs which we have. If we are talking about, for this one, remember it's for values of x less than -2, meaning we're talking about this going in this direction. We can see for this, as long as we are talking about for values of x less than -2, this function, what is its sign? It's negative. What of this one is also negative. So now just come back on here, we put a negative here, we also attach a negative here. And then between -2 and 1/2, this one, x plus 2 is positive, the 2x minus 1 is negative. So the 2x minus 1, I'm going to attach a negative. The x plus 2, I'll just attach a positive. And then going greater than 1/2, both are positive. So simply attach a positive here and a positive here. So this is what we mean when we say redefining a function. Now simply simplify what we have here. So this is going to be f of x is equal to, starting with this one, I'm going to multiply this negative, that will be -2x plus 1. These two negatives will form a positive, and then distribute that positive, that will be positive x plus 2. So if we simplify this negative, I'll start with this 1 plus 2 is a 3, and then -2 plus x, that is a negative x. This is for what? For x is less than or equal to -2. And then if we come to this one down, negative times this 2x is -2x, and then positive 1. Positive and negative is negative, and then we multiply that negative with what is inside, that will be -x minus 2. Add like terms again, -2x minus x, that is -3x, and then positive 1 minus 2, that is -1. This is between -2 and 1/2. And then for the one at the end, we have got 2x minus 1. We distribute that negative x plus 2. This will give us 2x minus x is x. Then -1 plus 2 is positive 1. This is for x is greater than 1/2. So we have now fully redefined, then we can sketch our function. I forgot for the previous one to state the domain and the range. We are going to see when I do this one. So we'll put the values that we have. The first one is x is less, we have got -2, our values of interest, and 1/2. Now, for values of x less than -2, for values of x less than -2, the function which is working is this one. The first thing that we are going to get is -2 itself. We put where there is x. That will be 3 minus -2. And that is going to give us a 5. So if, let me say 5 is here. So I've got -2, 5, which is somewhere there. Remember, this one is only working for less than -2. I can get another value which is less than -2. For example, a -3. If I put a -3 here, it will be 3 minus -3. That is going to give us a 6, to be somewhere here. Because this is a linear function, you can see it is going to be increasing in that direction as you go up. Between -2 and 1/2, the function that is working is which one? Is this one. If I get -2 again, I put here. It will be -3 times -2, which is 6, minus 1, which is 5. So again, this would be the coordinate there. The next one I'll get is get a number from -2 to 1/2. I can get a 0. Okay, I can get a 0. If I get a 0, I put here, it will give me a -1 as a value of y. So it means it's coming to cut here -1. And then I can also get the last one, which is 1 over 2. I put here. So that is going to be negative 3, 1 over 2 minus 1. So that is going to be negative 3 over 2 minus 1. This is of course over 1. So this is going to give us negative 3 minus 2 over 2. And that is going to give us negative 5 over 2, which is the same as negative 2, 1 over 2. Let me say negative 2, 1 over 2 is here. Or I can write it as negative 5 over 2. So this is the coordinate that we are getting here. So we can see this is also a linear function. So it's going to go like this. Okay, let's say this coordinate is supposed to be at this point. It's supposed to be linear. And it should be clear where it is turning. And then for values of x greater than 1 over 2, it is x plus 1 which is working. So if I get 1 over 2, I put here. 1 over 2 plus 1, that is giving us, and this one there should be a problem with the way I simplified it. Otherwise it was supposed to continue from this position, but it seems something wasn't okay here. I don't know if I missed a negative here or there was supposed to be a negative at that point. Whatsoever I missed. So let's say if I missed this as a negative, so that would have been 1 minus 1, that will still not be correct. So I don't know which negative I have missed at this position. Maybe I can just try to go back. So here we multiplied this negative with a 2. This was supposed to be a negative 2. So that is why things changed. So this was supposed to be negative 1 minus 2. That was supposed to give us a negative 3. So you see it will automatically refuse if you made a mistake somewhere. So that mistake was really big. So everything is all the same, or I'm just going to put them back the same way they were. Negative 2, we had this side, it was going like that, and then here we had the 1 over 2, and then the negative 5 over 2 function came somewhere here, and then it had to pass through negative 1. Okay, something like that. And then now from here we said if we get 1 over 2, we put where there is x. So that will be 1 over 2 minus 3. And that is going to give us, this is over 1, this will be 1 minus 6 over 1, which is the same as negative 5 over 2. It's supposed to be the same. And then we can get any value of x greater than negative 1 over 2. This is a 1 over 2 here, not negative. So we can get any value of x greater than 1 over 2. We can get a 1 and put in this function. If we get a 1, to be 1 minus 3, that is a negative 2. So you can see it has started going back again because this was negative 2 over negative 2, 1 over 2, negative 2 and a half. Now it has gone back to negative 2. So it will be somewhere here. What happens if we get a 2? We put here 2 minus 3, that will be negative 1 if we use a 2. So it will be somewhere. What if we get a 3? 3 minus 3 will be a 0. It will be somewhere here. So you can see the function has turned directions, that now it's going in that direction. So this is a sketch of this function. This is how it's going. So what will be the domain of this function? The domain is a set of values for which the function is defined. So this will continue going to the negative values like that, and it will continue going to the positive values like that. So it is for all values of x. from negative infinity to positive infinity. Now the range of this function, range is the y values for which the function is defined. The simplest y value we can have, we can't go beyond negative 5 over 2. So that's the smallest, negative 5 over 2. And then the largest, this function will continue going up, so up to infinity. So this is going to be the domain and the range of the function. Solve each of the following inequalities. So for the inequalities, we've talked about them a lot of times, so we can try out these. Sketch the graph of each of the following functions, state their domain and range, and clearly identify all the asymptotes. So for this one, I'm going to pick any two questions from here. Let me start with the first one. We can work out 3. The first one, I've got 7 over 5x plus 10. The first thing that we have to do, we have to equate the denominator to 0. If we equate the denominator to 0, 5x plus 10, that is going to give us that x is equal to negative 2. So this is the vertical asymptote. The graph cannot touch this value. Now, as long as the function is bottom heavy, you can see the denominator has got a higher power of x than the numerator. On the numerator, we don't have x, meaning that this function is bottom heavy. This will be the horizontal asymptote, the x-axis. So again, we can't touch the x-axis. And we can't touch this line which we've drawn here, which is negative 2. Now, how will be the graph? So simply, it can either be in this region, this region, this region, or this region. So to see in which region it's going to be, try to get any value in this region. You see whether it's going to be up or down, and the simplest you can get is a 0. If you get 0, you put here to be 7 over 10, and that is a positive value. It means that the function is going to be on top. So the function will be like this. We can't touch these values. We'll be going closer and closer, but will not touch them. Also going up. So if it is up like that, it means in the down here is going to be in the opposite direction. So that is how it's going to move. And the domain for this function, the x values, we can see the simplest x value we have is from negative infinity, and then we are coming to pause at negative 2. From negative 2, we can see this function is again continuing to go like that. So from negative 2 again up to infinity. The range of this function, the simplest we can have is negative infinity here. We cannot touch 0, which is the x-axis. And then from 0, we are going up all the way up to infinity. So that is going to be the sketch of this function. We can try also to work out b. F of x has been given as 6 minus x divided by x minus 3. Equate the denominator to 0, going to find that x is equal to positive 3. Now for this one, we can see that the denominator is not heavier than the numerator. They have got the same heaviness. This one has got x, this one has also x. So what you do is you just get the coefficient of x on top and the coefficient of x down. So that will give you negative 1 over positive 1. That will give us a negative 1. So that is a new asymptote in the horizontal. Now the question is saying clearly stating all the asymptotes. So vertical asymptote is x is equal to 3. Horizontal asymptote has changed. It is now y is equal to negative 1. Now we can try sketching it. If we get a value in this region, I'm interested in that region because it's simpler. We can get a 0 as x value. Let's put 0 here. It will be 6 minus 0, which is 6. 0 minus 3, which is negative 3. So I've got 6 divided by negative 3, which is a negative 2. And negative 2 is down. It means that when x is 0, the function is going to be down. So this function will be going like this. It will come and cut at negative 2, and then it will continue going down. This means that on top is going to pass there. So if one is in this region, the other one is supposed to be in the opposite region. This value, we are also supposed to find it. This happens when y is equal to 0. We're supposed to solve that. We just say 0 is equal to 6 minus x divided by x minus 3 cross multiply. Going to have 6 minus x is equal to 0. X is going to give us 6. So meaning that this is 6. So the domain of this function, we move from all the way from negative infinity. We are posing up 3. And then at 3 we continue up to infinity. The range of this function, we're moving all the way from negative infinity in terms of y up to negative 1. And then from negative 1 we continue up to infinity. So that is it. We can work out f of x is equal to 2 divided by x squared minus x minus 12. We equate the denominator to 0. We are going to find that what's the product? The product here is negative 12. The sum here is negative 1. What will be the factors? Is it a 3 and a 4? Which one should be negative? We need to have a negative 4 and a positive 3. Alright, so this is going to be x minus 4, and then x plus 3 is equal to 0. Meaning that x is going to be equal to positive 4, x is equal to negative 3. We have got positive 4, we have got negative 3. These are the the vertical asymptotes. Vertical asymptotes are found in terms of x. Horizontal asymptotes are found in terms of y. So these are values that we are not going to be able to cross. Now because this function is bottom heavy, this is going to be the horizontal asymptote, the x-axis. We can now sketch. To be able to sketch again, we can determine in which region this function is going to be. We can simply get x as 0. We put here 0 minus 0 minus 12, that's negative 12. 2 over negative 12 is a negative number, meaning that when x is 0, it's going to give us a negative number. So meaning that the function is going to be in this region when x is 0. So it is going to be going up, and then it will then start going down. We can't cross these asymptotes. And then definitely if it's in that region, then in these two regions, function is going to be opposite. So meaning if it was on top, they would have been here. So that is how it goes. Now we have got a turning point here. We have got a turning point at that position. To find the turning point, we need to use calculus. We need to find the derivative. We differentiate this function and then equate it to 0. Now I'm not going to do that because the turning point is important for us to be able to find the range. So the domain of this function, we can see we are moving all the way from negative infinity in x. We pause at negative 3, and then we continue from negative 3. We pause at 4, then we continue from 4 up to infinity. Now the range of this function, the smallest value that we have is negative infinity. We are pausing at where the turning point is. We need to find that turning point. And then we are continuing. If we pause from where the turning point is, we are continuing from the horizontal asymptote, which is 0, all the way up to infinity. So that is how we're supposed to put. Actually, the turning point, we're supposed to include it. because that's where we are ending. We know that value. We are touching the turning point, but we don't touch the asymptotes. So I've not put the value there because we don't know the turning point. We can calculate it, but I don't want to go into calculus for now because this is pre-calculus. I can work out just one last question. Let me pick E, where I've got f of x is equal to x plus 3 divided by x squared plus 4x minus 5. So for this one, what would be the, if we equate the denominator to 0x squared plus 4x minus 5, what are we going to find? The product is negative 5. The sum is 4. What are the factors? If we get 4, okay, that's a sum. We get a 5 and a 1. We want the product to be negative but the sum to be positive. So I'll put a negative there. So this is going to be x plus 5, x minus 1 is equal to 0. So this is going to give us x being equal to negative 5 and x being equal to positive 1. Let's say we have got a negative 5 at this position and a positive 1 at this position. These are our vertical asymptotes. What will be the horizontal asymptote for this function? So the horizontal asymptote for this function is going to be, you can see the function is bottom heavy. The denominator in the bottom, I mean the value of x in the bottom is bigger than the one on top. That's why we're saying it's bottom heavy. Now because even if the function is bottom heavy, we still have x on top. Is going to be a peculiar question. It's going to be different from this we've been working out. So what I'm going to do is I'll get the factors which are equated to 0 in the denominator. What am I going to do? I'm going to put on a number line. Also equate the one on top to 0. We're going to find negative 3. So I've got negative 5, negative 3, and positive 1. I'm getting these values, and the one I've equated on top. We'll get the factors that we equated to 0. We have got x plus 5 we equated to 0. We have got x plus 3. We also have x minus 1. Now when we equated x plus 5 to 0, we found negative 5. If I use any value of x greater than negative 5, I put in this function, for example, negative 4, it will give me positive. So immediately I cross the negative 5, it will be negative. When I equated x plus 3 to 0, I found a negative 3. If I put it, I get any value greater than negative 3, like a negative 2, I put there, it's going to be positive. Immediately I cross a negative 3 to be negative. And then in x minus 1, we found 1. If we get a value greater than 1, like a 2, it will be positive. Less than, it will be negative. If you see this fact, we have got a factor on top, and these other factors are in the denominator. They are dividing and multiplying. So if you divide and multiply signs, the signs change. So this is going to be negative times negative times negative is negative. This will be positive. This will be negative. This will be positive. So remember, this is a 1 at this position, and then a negative 5. Let me also include a negative 3, which is going to be somewhere here. So we can now sketch our function. So between negative 5, of course we know that this is horizontal asymptote. Don't forget that. Between Okay, for values of x less than -5, the function is negative. This means that the function is going to be below the horizontal asymptote. That's the meaning of negative. So it's going to be in this region. Between -5 and -3, the function is going to be positive. -5 and -3 function is going to be positive, meaning that it's following this asymptote, the vertical asymptote, and then it is coming like this. And then between -3 and 1, the function is negative. From here up to here is negative. How come it has gone to the negative? That is because it crosses the asymptote. Now the vertical asymptote can be crossed for small values. It's actually found as a limit to infinity as x approaches infinity. So you don't touch this line as you go towards infinity, but on the middle you can touch it, as you are able to see for this one we have touched it. Okay, and then for values of x greater than 1, the function is going to be what? Positive. So it is going to be on top here for values of x greater than 1. So this is a sketch of this function. That is how different it is from these others we are sketching. So you need to take note when you have got a letter on top, even if the denominator is heavier than the numerator. So the domain of this function is going to be from -infinity, you pause at -5, and then from -5 you pause at 1, and then from 1 up to infinity. But the range of this function will be from -infinity to +infinity. That is because this line has joined everything. There is no value of y that you can't have. You're actually having everything. So the others, we can try them in a similar way. Find the set of real values of x for which 1 is less than 2 minus x divided by 2 plus x, and that is less than or equal to 1. Want to find the set of values of x for which this function is going to be defined like this. Now the question is, how do you get to work it out? You can see you have got this side and then you have got this side. So in this case, what we are going to do is we just want to remain with x on the middle. I can actually split this function and look at it on both sides. So I'll take it on one side as 1 is less than 2 minus x divided by 2 plus x, and then I also say 2 minus x divided by 2 plus x is greater than or equal to 1. So we work with it in this way and then we'll find the values. So then how do you work it out? Remember we said for rational inequalities you don't cross multiply. So simply take 1 this side, and that is going to be 0 is less than 2 minus x over 2 plus x. It becomes minus 1. Of course this is over 1. We can continue from top. That is going to give us 2 minus x. Then we multiply this negative by what is down. That will be -2 minus x, and then the two denominators, that will be 2 plus x. So give us 0 is less than, this will cancel with this. This will also cancel with this, as we can see. So I've got a 0 on top, then down I've got 2 plus x. So from when we have got a 0 on top, 0 over any number, the answer is 0, right? So the answer is 0. But I'm just going to get the denominator here. I equate it to 0. I'm going to find that x is equal to -2. X is equal to -2. Alright. Now I'm not going to proceed from there. X is equal to -2, but we don't have any factor on top. What are we really talking about? So what happens is when you are solving these equations, you are supposed to get the value which is on top. Let's say x is equal to 0. You write that 0 here, and then the other one we have is a negative 2, and then you start finding the values. But the only thing that this is teaching us is it doesn't matter. We have found that x is equal to negative 2. Whether you go to values of x greater than negative 2 or less than negative 2, you will still get 0, meaning that there is no value. You still get 0. Because any number divided by 0, the answer is, any number into 0, the answer is still 0. So for that one, there is no set of values. And then we'll come to this other side. Take one this side, that will be 2 minus x divided by 2 plus x less than or equal to, sorry, I'm supposed to put this one at that position, and that will be greater than or equal to 0. We need to merge this as a single fraction. That is going to be 2 minus x. Okay, so this is over 1. Then we'll get this value here, we'll multiply with what is in the denominator. So I first got a 1 here multiplied with what is on top. That is what gave us that. Then negative 1 times 2, that will be negative 2, and then negative x. And then divided by 2 plus x. And that will be greater than or equal to 0. So what do you think we proceed with here? We simply simplify what is on top. So that is going to be 2 minus 2, that is going to be a 0, of course. Then negative x minus x, that is negative 2x. And then divided by 2 plus x is greater than or equal to 0. Equate what is on top to 0, we're going to find that x is equal to 0. Equate what is down to 0, we're going to find that x is equal to negative 2. And then you are going to bring what we equated to 0 here. You have got a negative 2, you have got a 0. The factors that we equated to 0 is negative 2x and 2 plus x. Now we proceed. How do you proceed from this position? When we equated this one to 0, we found 0. What happens if I get a value of x greater than 0? For example, a 1 I put here. How are we going to find that one? So in a case of a 1, we are going to get negative. So this side is going to be giving us negative values. What of this other side? Okay, what of immediately we cross the 0, like for negative values, we put here negative times already negative, that will give us positives. When we equated this one to 0, what did we find? We found that x was negative 2. If I use any value of x greater than negative 2, like a 3, a 4, I put it to be positive. And then below that it will be negative. We're interested in the product of these signs, negative, positive, negative. For this one, we're interested where it is greater than, meaning positive. So the values are going to be between here. Now this is greater than or equal to, meaning that you're supposed to include also these values. But because when we equated the denominator to 0, we found a negative 2, we can't include negative 2 even if the question is including, because the denominator cannot be equal to 0 by any means. Okay. So this means that our values of x are between negative 2 and 0. So this is going to be our solution set, and that is how you get to work out this one. And the last question here, sketch the graph of the following functions: x squared minus 2x plus 5. Now we've already worked out similar questions, just that we've introduced a radical. So starting with the first one, I've got f of x is equal to absolute value of x squared minus 2x plus 5. This is a quadratic. Let me first work out what is inside. I just work it out as a quadratic. I'm going to complete the squares and then sketch it. So when you complete the square, you need to make sure that there is a 1 in front of x squared, and that is already true. Next thing, I'll just write x. I'll take the half of this number, that is a negative 2x. What is the half of negative 2x? Is just a 1. Don't write x and put a square here and then subtract. You get this number which is inside here, you square it, that will be a 1. You always subtract here, always, whether it was positive or negative, and then write a 5 at the end. And that is going to be x minus 1 squared plus 4. So I've completed the squares. So from here we can determine the turning point, and that is we just equate this one to 0, or we change the sign of the one, that is positive 1 comma 4. Just get this one, you don't change the sign. So the turning point is at 1 comma 4. Now we can see this function is positive. The function is positive. Is it going to have a maximum or a minimum? We expect it to have a minimum. So another thing that we're able to do is we can try to find the intercepts if we want to determine whether it's going to have a maximum or a minimum. If it's going to have a maximum, it's going to have intercepts because it's going to go like this. It means it's cutting x somewhere. But if it's going to have a minimum, it's not going to have intercepts because it's going like that. There is no point where it's going to cut x. So how do you determine that? Simply find the discriminant d, which is given by square root of b squared minus 4ac. b is negative 2 squared minus 4, a is 1, c is 5. You can see this is negative 2 squared is 4 minus 20. So give us a negative number, meaning that the discriminant is negative, which means this function is going to have no intercept. So it's going to go up like that and also come like that. All we need to find is this point where it's cutting the y-axis, and that happens when x is 0. So just put a 0 here, a 0 there. What are you going to find? It's a 5. Now because this is absolute value, what does it mean to have absolute value of a function? You simply overturn it. Now the absolute value of this function is, it will still be itself. Okay, it will be itself. So for this one, it is okay. So imagine maybe if the turning point was at 1 comma negative 4. Let's just take it like that so that we understand. Maybe that's how the other question would have been. So if the turning point was at 1 comma negative 4, how would the function have moved? So it would have been here, it would have gone in this direction, like that. Now if you put absolute, it means the function, we can't have the part that is on the negative side. So the part that is on the negative side, we reflect it. So it now changes direction. So that is how we would have reflected it. This negative 4, which was negative, it would have become the positive 4 in terms of y. So just change y values. Let's say if it was cutting at negative 3, it would have gone to positive 3, and then would have now removed this part which is down. But because that function was already up, it is okay with that. Let's just try now one more, or let me do 2. We can try this one, which is f of x is equal to absolute value of 1 over x. Now just 1 over x itself, when we are sketching, remember we said equate the denominator to 0, we're going to find that x is equal to 0. So meaning that asymptote is going to be at y is equal to 0 and at x is equal to 0. When you put any number greater than 0 for x, like a 1, put a 1 there, the function is going to give you positive, meaning that the function is going to be in this region. When you use a negative value, it will come in this region. Now absolute means you can't have a function being in a negative region. So this function which is here, because it's absolute, we are going to remove it. We are going to reflect it to the positive direction. So it will now come here. So that is how the function is going to move. Okay, now try out C. F of x is absolute value of 9 divided by x squared minus 9. Equate the denominator to 0. We're going to find that x is equal to 3 or x is equal to negative 3. So those are the vertical asymptotes. Say a positive 3 is here and a negative 3 is at that position. And because this function is bottom heavy, it means that the vertical asymptote is going to be at x is equal to 0 or at y is equal to 0, that is the x-axis. Now if you look at this function, trying to get a value of x in this region, like a 0, you put a 0 here, you are going to have 9 over negative 9, which is negative 1. Because this function is symmetrical, this is supposed to, I'm expecting this to be the turning point. It's supposed to go like that. And then definitely in this region, then it's supposed to go in like that. And then in this region, it's also supposed to go like that. Now, because this is absolute, we can't have this one, which is in the negative. So where the turning point is for negative 1, it will become positive 1. And it changes direction. So it will now be in this region. So we will no longer draw this part which is down because we have reflected the graph. So that is how we get to sketch these functions.